Hey, ladies and gents, happy Thursday. You should be watching this. If it's a different day, cool, you're still watching it, so I'm proud of you. Today, we are just going to simply review combining like terms and a little bit of multiplication from the previous lesson, and then give you a time to practice. So it should be hopefully, as long as I don't talk too much, a little bit shorter of a video. If you want to follow along on Agile Mind, we are under My Courses. Under course contents, we are still in Unit 8. Drop down arrow next to topic 23. Drop down arrow next to lessons, and we are on lesson 6, adding and subtracting polynomials. Now you'll notice I've already hovered over those 3 dots and gone to page 6 because that is what corresponds to the page in the workbook that we're going to be starting on. In the workbook, we are going to be starting on page 346. So while you get flipped to page 346 and logged into Agile Mind if you would like, I am getting my computer set again, page 346, and I'm right here in the middle in 5 and 6. So in the previous lesson, we talked about multiplying with polynomials. Now, I suppose we could do a little bit of review. I'll actually just use this empty space on page 347 to help out. We know that polynomial, that prefix poly, means many. So polynomial refers to many terms. Specifically, many has to be 4 or more terms, because anything under 4, we have another special name for it because we see 1 term, 2 terms, or 3 terms so often in math. If we have 3 terms, and think about my analogy to riding a bike with 3 wheels is called a trinomial. So a trinomial refers to 3 terms. If you are riding something with 2 wheels, you are riding a bicycle. So a binomial refers to 2 terms. And again, I realize if you're riding something with 1 wheel, it is a unicycle, but we do not have a uninomial. Instead, that is called a monomial. And a monomial refers to having simply 1 term. And if you remember, terms, we can identify them because terms are separated by plus and minus signs. Terms are separated by plus and minus signs. I'll just make a note here. Terms separated by plus or minus signs. Separated by plus and minus signs. We know that anytime we are combining like terms, we are combining things that have the exact same variable and the exact same exponent. Like terms mean the same variable and same exponent. And when we refer to combining, sorry, I got to get comfortable over here. When we refer to combining, we are referring to adding and subtracting. Combining refers to add or subtract. So we are simply going to do some adding and subtracting right now. That is it. So if I look at number 5, we know that this is addition because we see that plus sign. Now, we don't have to do any classifying, but all these parentheses are here for is to tell you that these 1, 2, 3 terms stay together. So this is a trinomial, and these parentheses indicate that these 1, 2, 3 terms form their own trinomial. However, the process of adding is saying, hey, combine these together. Tell me how many total you have. And we know if we are combining, in this case by adding, we need to look for things that have the same exponent and the same variable. Now in this case, it's already grouped together. We have 25 and we have -4. They're constants. They have no variables, so they are considered like terms. So 25 and -4, if I combine them together, is 21. Now, some of you may be thinking, but this is addition. Why did you use a minus? Well, you can think of this as 25 plus a -4. I like to sometimes think of combining not as specifically adding or subtracting, but I like to think of it as just putting together the like terms based on the sign in front of them. Think of combining just as combining. I am putting together the 25 and the 4 based on the sign in front. So 25 minus 4 is 21. Looking for more like terms. Well, this -14 has an x, so I'm looking here for something with an x, which is +3. So based on the sign in front, -14 plus 3 means I have -11 x's. And I got to remember to have that x there because I could put them together because they had x's. Now, just to keep terms separate, that 21 was positive, so I'm going to put a plus sign in there. I should have done that previously. And last but not least, 7x's squared. The other like term would be these 3x's squared. So together I have 10x's squared. And just like that, we combined like terms specifically by adding, but again, you can think of it as just combining them based on the sign in front. Now you will notice that this one is written sideways. Totally okay. I'm going to look in between this 1, 2, 3 trinomial and this 1, 2 binomial to verify what operation we are going to do. And I see that this is, again, addition. We are adding. So again, we are looking for like terms. So starting with my 3x's squared, if I scan across looking for another x squared, I have this -x squared. So if I have 3 here, then the question is how many here? Well, I see a negative, but I don't see a number. Remember, we can always put a 1 in there. So 3x's squared minus an x squared means we have 2x's squared. Moving over, I now have this -x, and again, I like to throw that 1 in here. So I'm scanning for anything else with an x, and I don't see it. 2 doesn't have one, 16 doesn't have one. So what do we do with this -x? We bring it down. If you want to keep the 1 in there, totally okay. 1s are not necessary, but they're not wrong if you write them. And so then last but not least, we have this +2. Looking for any other constant, anything else without a variable, and I have the 16. So combining a 2 and a 16 gives me 18. And there you go. We just did some more combining of like terms. I'm going to move over to page 347, and we're going to combine in number 10 and 11. Page 347, number 10 and 11. Notice in this case, we have moved to subtraction. So how is subtraction any different? Well, subtraction really means we are doing the opposite of what sign is in front. We're still looking for like terms. We are still looking for the same variable, same exponent, but subtraction really means I need to do the opposite. Now, personally, I think the best way to remember to do the opposite is to first distribute that negative to everything that comes after it. That helps you remember that I need to do the opposite of what I started with. So I'm going to distribute. That helps me quite a bit. So I need to do the opposite, and I'm going to distribute to the end of a -1. Well, the opposite of a negative is a positive. So I'm going to switch that to a positive. I need to do the opposite of adding 4x. So a negative times a positive, I need to do the opposite. I need to subtract that 4x. Make sure you write those signs big enough that you can see them. And last but not least, I need to do the opposite of just having 3x. Well, that 3x squared, is positive. I need the opposite, so I need it to be negative. Now that we've distributed that negative, now that we've shown we're doing the opposite, I can really get rid of it because I already applied it to every term following. So then at this point, we really can go ahead and just do our combining of like terms. So here we go. We'll start at the beginning this time. 6x squared can go with these now negative 3x squareds. So 6 minus 3, we have 3 things left that have an x squared after them. Moving over to our x term, we have -7x's. And now that we've applied the subtraction and done the opposite, we have a -4x. So we have -7 here, -4 here, -7 and -4 make -11 things that have an x after them. And last but not least, we have a 5 and a 1, and 5 plus 1 is 6. Technically, you just subtracted because of the minus sign that was there. But again, all adding and subtracting is called combining like terms. So we just successfully combined like terms. Moving on to number 11. Number 11, again, I'm going to look inside or in between, the parentheses to check what operation I'm doing. That's super important. We have 1, 2, 3 terms, a trinomial. 1, 2, 3 terms, another trinomial. Looking in between, we are technically subtracting. But like I said before, it can be really, really helpful rather than having to remember, oh gosh, I have to subtract. Think about doing the opposite. And the best way to indicate you need to do the opposite is to distribute that negative sign before you even begin combining like terms. So I'm going to go through and do that first. I'm going to distribute that negative sign to everything following. So I need to do the opposite of having a 4x squared. So I'm going to subtract of 4x squared. I need to do the opposite of adding x, which of course is subtracting x. I need to do the opposite of adding 9, so I need to, of course, subtract 9. Now I can go ahead and bring down everything else. You may be thinking, well, Mrs. P, what happened to your parentheses? Well, when I'm combining like terms, parentheses, again, really, really not super important. They're important at the beginning for me to help identify what operation am I doing? Am I adding? Am I subtracting? Am I multiplying? Am I dividing? But those parentheses otherwise are just saying, hey, this group formed its own trinomial, or this group formed its own trinomial, binomial, polynomial, whatever it happened to be. Once you have identified what operation you're doing, in this case subtraction, it's really not necessary to have those parentheses anymore. And since I took care of doing the opposite, took care of distributing my subtraction sign, now I'm just going to look to combine my like terms. So I have an x squared term right here. I'm going to scan through for my other x squared term, which is right here. 5 x's that are squared minus 4 x's that are squared leave me with 1 x that is squared. Again, that one is optional. If you don't want to write it, totally okay. Now I'm going to look here. I got a negative x, going to scan for another x term. I got another negative x here. Now, I don't see any numbers, but remember, imaginary ones right there. So negative 1 minus another 1 would be negative 2 things that had an x after them. Last but not least, I got 2, which is a constant. There's no variables. I'm going to scan for another constant, negative 9, and 2 minus 9 is negative 7. We just combine this trinomial and this trinomial to form another 1, 2, 3. This also happens to be a trinomial. We just combine two trinomials to make a trinomial. And we did so technically by subtracting. But again, really, subtraction just means do the opposite of everything coming after it. We combined these trinomials to form a new trinomial by combining like terms. Okay, I am going to flip the page. You can go ahead and flip your page as well. And I am just going to use the blank space on the bottom of page 348 just to write out a couple problems. This is not number 13. I'm just going to, again, write out a couple problems. So you may copy them as well. Got 2x plus 4, x plus 2, and 3x minus 6. Okay. So now glancing at these problems, they probably seem or look pretty similar. But when I pay even closer attention, the important part to pay attention to specifically is what's happening between these parentheses. If I look between these parentheses, I see a subtraction sign. If I look between these parentheses, I see nothing. So what does nothing mean? Well, if I want to add, I have to see a plus sign. If I want to subtract, I have to see a minus sign. So we have to think, what operation do we not have to see any sort of sign? We say, aha, this must mean multiplication. This means multiply. Adding, subtracting, dividing, you have to see a symbol. Multiplication is the only operation where we don't have to see a symbol. So now is when we have to think about, okay, what are the rules for subtracting versus what are the rules for multiplying? Well, let's go with the subtraction first. Subtraction, we know that means I need to do the opposite of everything that follows. So I need to do the opposite of having a positive 2, which is a negative 2. I need to do the opposite of adding x, which is subtracting x. Now that I've identified the operation, now that I have dealt with the operation, I did the opposite, I can really lose the parentheses and bring down everything else that follows. And now we're going to look to combine like terms. So I see I have a 3x, scanning for another x term, I have a negative x. Imaginary 1, so 3x's minus 1x is 2x's. And I have a negative 6, which is a constant term, no variables, and a negative 2, so negative 6 minus 2 is negative 8. We just technically subtracted, aka we combine like terms. We combine like terms to create 1, 2 terms, which I'm going to go ahead and practice classifying, is called a binomial. 2 terms is called a binomial. Now, again, in this case over here, we realized nothing in between. So important to check in between the parentheses. It's really going to be your test for the little bit of work I'm going to ask you to do later today or after this video, is to really be paying attention to what operation we're going to do. No symbol means it's multiplication. So let's think about how we multiply. Okay, that is what we talked about last video. Multiplication, we can either do that distribution property, which has that FOIL acronym, or the one that I frankly think is the easiest to just, the easiest method to do multiplication is to create that box. Okay, so creating our box, what goes across the top of the box? Well, something within one of my parentheses. So across my first box, I am going to put 2x and 4. Now, 2 terms, that plus sign, if you recall from before, is really where we cut our box in half. And notice now that I've identified what I'm doing, I've set up that multiplication. I've dropped the parentheses around the 2x plus 4, which means the x plus 2 is going to go down the side, and I am going to cut my box there as well. Notice again, I've identified the operation, I've set up the operation, I've lost my parentheses. Now we are going to go ahead and perform the multiplication. So here we go. X times 2x, well, the 2 is nothing specific to multiply by, but x times x is x squared. X times 4 is 4x, bottom right. 2 times 4 is 8, and 2 times 2x, 2 times 2 is 4, bring down that x. Again, this is really just an organizational tool, so I'm going to pull everything out of the inside of the box. So we have 2x squared plus a 4x plus another 4x plus 8. I'm going to scan for like terms. I see nothing else that is squared, so I'm going to bring that down. I have 4x here and 4x here, which is 8x's. And I have this 8 at the end. It's only constant. We multiplied. We identified based on what was in between. We set up. We dropped the parentheses. We multiplied, and we came up with a final answer of 2x squared plus 8x plus 8, which is 1, 2, 3 terms, which bike with 3 wheels, tricycle. So 3 terms is a trinomial. So today, for your short 4-question assignment, I want you to focus on what operation am I doing? How do I set up that operation? And how do I execute that operation? Today in your assignment, you're also going to be asked to identify your final answer is a monomial, binomial, or trinomial. Just practice with some vocabulary. You have a nice and short video today. So go get your short homework done. And if you have any other catch-up work, you have a great opportunity to get caught up on that as well.